All right. All right. Should I just, okay. Hello, everyone. Welcome to Dev Shop. The talks will be beginning momentarily, so if you would silence any of your devices that make sound, that would silence or put on vibrate, your phones and stuff like that. That would be super appreciated. Also, the door in the back of the room will not be open during the presentation, so if you want to get some seconds, get some dessert, now would be a good time to do that. All right? Oh, and one last thing. So for people who are in the front tables, just so you know, some tables are like visible during crowd shots. So yeah, table 3, 6, and a little bit of 4. So if you, for any reason, are uncomfortable being part of a crowd shot that's being streamed, feel free to reshuffle as necessary.
Can I get the second speaker on the convention line? Seems like now's as good time as any.
everyone. Welcome to Devshop. Please be seated. This is Devshop 9, so it's our 10th Devshop. Happy Halloween, everyone. Woohoo! Our first speaker is Ritik Malhotra. Ritik is a 2012 Teal Fellow and YC alum. In the past, he started a profitable web hosting company, created a web forum that received over 6 million hits in less than a year, was a finalist at the International Science Fair, and worked on the growth team at Twitter. He is currently a co-founder of Stream, a venture-funded YC-backed startup built on top of Meteor. And Ritik is going to tell you about building a production-ready Meteor app.
Hello, testing. Hey guys, my name is Ritik, and as Andrew just mentioned, I'm working on a thing called Stream. We built our app in Meteor, so I came to give a talk today to give you guys a little more insight on how we did that and how to actually build a production-ready Meteor app. So one of the things that people have been saying for a lot of the past months is that Meteor's this cool technology. It's great for building toy apps, but how do you actually get past just building something that's like 3 files big, and something that can actually scale and I can actually use for my production app, or something that just is something other than that what I want to show on Hacker News or something like that. So basically today, that's what I'm going to go through. Some of the things that we did, how we set things up on our side, and how to actually build something that goes beyond the toy app phase. And questions can come at the end. So there's really 4 components that go into building this production-ready Meteor app, right? So the first one, and I think a lot of people have this question, is what is like the app structure supposed to look like, right? In a Meteor app, there's the examples that show you, well, there's 3 files, HTML, JavaScript, and maybe one other one that's or the CSS, obviously. There's nothing that goes past that, right? So if you want to make one that has multiple pages, has a router behind it, and has a lot of different moving parts, how do you actually structure this app, right? And then some other questions might arise when you're going down this lane. It's such as like, what packages do I use? Like, what is the concept of packages? Which ones are good? What actually will help my app, and which ones are necessary? And then obviously the other one is, how do I actually architect this on a production server so that I can actually get this past one server? Let's say I get a lot of users on this app. Will this thing scale? How can I make sure, and how can I actually load balance everything and get all that stuff up? Things that you might be used to if you've used other systems like Rails and things like that, but it's not as obvious when it comes to Meteor. So these slides over here are more of a resource. It'll be up online. And hopefully you can refer to them at some other point. And people will hopefully build on top of this and release more information about how to do these things in the future. But hopefully this is a good guide to start out with. So one of the general philosophies that that we took at Stream, at least, on building a production-ready Meteor app was that we wanted to keep everything that Meteor does intact, right? So like build around what already exists, right? So that might mean adding packages, or monkey patching some things if things aren't what you wanted to work as, so that's kind of the philosophy that we went with, and that's what I recommend, just because it's really easy for you to upgrade Meteor as they release more things out into Meteor Core, and just makes for a much simpler experience. And obviously, the first step whenever you're doing this is remove the 2 packages that come with Meteor, auto-publish and insecure. These will obviously not work in production. Auto-publish will automatically publish every single document in your database to the client, and unless you control that, which you should be in a production app, that can get bad really fast if you have thousands of documents. And insecure lets anyone do any database writes, which is obviously a security risk, and that was addressed in Meteor a while back. So the first thing is the app structure, and basically I'm going to outline one of multiple ways you potentially could structure an app, and hopefully this gives some insight on if you want to make your own app structure, or how to actually architect this whenever you're doing your big app. So the app structure right now that you probably know of, if you read through the Meteor docs, looks something like this, right? You have the client, you have the server, you have a bunch of other things like the public assets, private stuff. You might have your tests, you have your packages, a common folder called lib, other folders that are common between the server and the client. It's not obvious when you read the docs as to how you want to structure your app just by looking at this. So let's take a look first at the client side stuff that you might want to build. And it might be a little small, but hopefully You can look at these later if you never need them. So on the client, the main things when it comes to the app, you have the regular stuff that you would see in a regular web app, right? That makes your CSS. It's obvious. Your JavaScript, which is your third-party libraries that you might have, like your jQuery libraries and things like that. And then your views and your lib folder. So the two things that are really unique to Meteor are these two things, right? So the lib folder in Meteor, for those of you that don't know, is the thing that gets loaded first. So Meteor has a special load order that actually loads things based on based on the file name. And the lib folder, anything in the lib folder gets loaded first in Meteor. So this is a great place to put things like your helpers, right? For example, you have client-side helpers such that might do that you might be doing a bunch of jQuery and a bunch of times. You put this in your lib folder so it gets loaded first and it's accessible in any of your other views or something like that. And then you have your Meteor-specific code, right, that goes in your lib folder because you want this loaded because this is your core of your app, right? And this includes things like your router, right? So the router in Meteor is different than what you might have seen in other frameworks. What I mean by that is that routing is done on the client side. You might be familiar with this if you use other client-side frameworks. But for example, this isn't as obvious if you're using something like Rails. So client-side routing, you put your routing stuff in here. You want that to be loaded, obviously, initially. And then you have these two other files, which are called startup and subscriptions. So in Meteor, there's also this concept of meteor.startup, right, which is basically code that needs to be run as soon as that file gets initted, or as soon as the client is initializes, right? And you might want to run some things like set some sessions initially, or seed the database because this client is now connected, or do something initially when the client connects. If you're building a chat application, make his status online or something like that. So that code goes into here. Subscriptions is essentially what you would have to do to subscribe to your actual data, right? So you subscribe, a new user signs into your app. And then you can subscribe to the data, whatever. So maybe it's the chat room. You want to subscribe to all the chats in that room. You want to do it over here because you want to get that data initially, and that's the first thing you want to do before you load anything else. So again, a lot of you might find this obvious. It's all in the docs, but hopefully this gives you a more structured way to put it. The last thing on this one is views. And this is actually where it gets a little more complicated because if you're building a large multi-page app, the question is how do you actually structure these views and how do you actually route things between them, right? So the way that we do it is we have a views folder, and inside that is you have separate folders for each group, right? And what is a group? Something like accounts, right? Accounts might have your login view, register view, forgot password, anything to do with logging in or accounts of some sort. And you have groups like this, and each view has its HTML, which is your template, and then has also the JavaScript file, which is the controller, which has the template.helpers, events, what happens on the rendered. Again, these things are in the docs, but basically the point is every group has a bunch of views, and every view has a template and a controller that controls it. So with these multiple views, you can use the router.js file to route things between them. So if you go to a different route, it'll automatically load a different template, and I'll get to exactly what you can use for the router. So the next up, if you go back, if you remember, there was that's a client directory, and that client is actually probably the most important part because this is a client-side app. The next thing is actually the lib directory. So anything that's not in the client and the server folder in Meteor automatically is shared between both the client and the server. So in the lib folder, essentially you have two things, right, that we usually put, and this is basically the helpers and the models. So helpers, pretty straightforward. Things that any helper model, helper functions that are shared between the client and server. Things like maybe string base name, is valid email address, simple things. The models is a little more intricate in the sense that there's a concept in Meteor of how collections exist both on the server and the client. And in the models, what we do is basically we initialize all the collections that we're using and that we want shared both on the server and the client. What we actually do is we take the concept from Rails on having very fat models in the sense that we abstract all our database queries out to these model files. So for example, Meteor actually lets you do raw database queries directly in the server side and client side code, and you'll see all the examples actually show you doing the actual database queries there. But if you're building a large scale app, you want to abstract these things out to actually more helpful functions like user, in the user model, you want to do like user dot get username or dot set notification setting or something like that. That is a little more descriptive, more Rails-like, but I think it's a little better for your app because it's a more descriptive name. You can reuse it in multiple places without having actual raw database queries littered over your code. So the next part of the app structure, this is kind of the other crud that just goes on with Meteor. You have your packages, that comes in from it's similar to what like a Ruby gem or like an npm package or something like that, and you can use Atmosphere or Meteor, right? These are two great programs that'll let you get packages pretty easily, and you have these two folders called private and public. Private is exactly what it sounds like. It's files that are private that you want access on the servers, things like your email templates, raw files that you just want to load directly. And public is all your public assets. And then obviously you have your test suite that you can add, and I'll get into that later. So the last part is the server-side code, right? So in the server, you might have a variety of things, and the first thing on the list is actually the API. So the concept of an API is actually is not documented in Meteor, because Meteor is all about the client and the server communicating with one another, right? And ideally, this would be true for everything. But if you're building a large-scale app, you might have a mobile client or some other external API that a third party wants to hit. And for this, you still need to adhere to REST principles. And this is a great place to put an API and actually declare your routes. So these are like your standard server-side API routes, and you can configure that on the server. Then you have other things like your config. You can configure accounts. What happens when a new user's created. Straightforward stuff. Helper functions. You have your lib folder. Again, the lib folder is the one that's loaded first. And this is a great place to load things like what happens on the server startup, or initializing your npm packages or something like that. So everything that you want loaded first. And then you have your models, if you have any server-side models or anything like that. And your publish function, and this one is most important, because this basically dictates exactly what you want to publish to the client, in the sense that what data goes to a client based on what permissions the client has. And again, I apologize if a lot of this is just information you already know, just by reading the docs. But hopefully this gives you some idea of how we actually structure our app and how you might want to do it in the future. So you got the app structure down, and you're trudging along. And actually, how are we doing on time? Left? Yeah. Oh, OK. So the app structure is pretty important. And there's a lot of good packages that you want to include as well. But I'll skip over this and maybe do this in a different talk then. And you can reference it in the slides. But packages are really important just to actually, you guys have all may have used them in different languages. They have the same function in Meteor. This is just a quick list of essential packages, basically a filtered list of what you want to use in your apps. But you can reference it later. I'll go through it maybe in a different talk or something. But the more important thing, I think, the one that hasn't been touched on at all yet, has been server architecture, right? So like, you guys know how to deploy an app. You can do Meteor deploy. It goes to meteor.com. You can deploy it on Heroku. All of these things are great if you want to build your small apps. But if you want to scale past one dyno or one instance, it's very difficult to actually figure out how to do that. How do you make something that automatically will scale up? If I have 100,000 people, or 10,000 people hitting my website, right? One dyno will not be enough. Heck, maybe even 10 instances won't be enough. I need this to actually work. And this is where we had to think of some other creative ways to get around this problem. So one of the common things that people kind of wrote this off initially. They were like, well, Meteor's not scalable yet. They'll get to it later. This isn't ready for production. And luckily, that's not true. There's actually a variety of solutions, and I'm going to outline one of them. So first, let's start with the problems, right? So there's multiple components that you have to think of when deploying any app, right? And specifically in Meteor, right, there's a few problems. So there's the standard components. You have to think about how you want to deploy it. Pretty straightforward. You want to have support from multiple web servers, so you can actually scale your app across different instances, right? And you want to have it load balanced properly, and so that you get users scattered across your instances. And obviously, you want to have the core part of your app, the database, has to be scalable in some way. That in Meteor's case, there's a lot of other nuances, because Meteor's all about syncing data in real time all the time. So a couple of problems arise from this. And number one is that there's a problem of data synchronization, right? Because the entire point of Meteor is that you're always communicating with the server as a client and synchronizing your data to the server, so that the server can update the database. And then all the other clients get the updates immediately. This is the entire concept of the whole reactive real-time Meteor app. The problem is, if you have multiple servers, how do you, as one client, tell 1,000 other servers what exactly what data to synchronize? So that's problem number one. Problem 2 is that in Meteor, everything is based off of what's called a sticky session. So how Meteor is built is that a client is connected to a server, and it has to stay connected to that server for that session. So you can't do load balancing appropriately like how Heroku does with round robining, which is called, every time you do a request, it will send me to a different server. And so that's a problem. We have to figure out how do we get around this issue. We can't use Heroku for this, obviously. And third one is the database problem, which I'll get into at the end. So for deployment, you want something that's actually something that's reliable. And for this, we chose Amazon. And there's obviously a bunch of solutions out there. Rackspace, Amazon. There's a couple of other ones, Modulus.io, all these other ones that have been popping up recently. But we wanted to go with something that has a good name, and Amazon was obviously the one Amazon was one of them on the top. And for this, we actually used Amazon Elastic Beanstalk. For those of you that haven't heard of it, it's essentially I would say Heroku for AWS. Definitely check it out. It handles a lot of things like managing server instances, load balancing, asset delivery, monitoring, scaling, and things like that. So it's essentially what you would use Heroku for. A little more complicated, but that actually works to your benefit because it works with Meteor well. So I'm basically going to go through a configuration how we did this and show you a little diagram of how we have the server architected. But essentially, we used, so standard on Amazon is the EC2 instance. That's essentially your web server, Elastic Web Server. These are all details over here. But basically, we're using EC2 set with setting. You can actually set them to do auto scaling, which is essentially if the CPU usage hits 60%, it'll automatically add another EC2 instance, and if it hits below 30, it'll take one down. So this is great because then you don't even have to worry. If you get 1,000 influx of users, then it'll automatically keep adding instances until your CPU is scaled, is leveled off. And if you don't have that many users, it'll take them all down, which is exactly what you want. Now, the second thing that we were talking about is also load balancing, and Amazon also comes with a solution for this, Amazon Elastic Load Balancer. Now, the one issue that we mentioned with load balancing was that you always, remember, because Meteor is built so that one client always has to be connected to the same server, you want the load balancer to make sure that that always happens, and this is the concept of what we were calling the sticky session, right? So luckily, Elastic Load Balancer actually lets you do this. Right. So again, there's details in here. Things like the settings you want to set. But it's just good to relay this information so you can configure this later at some other point. The database now is actually the most complicated part, right? Now you have this entire solution built out, but the problem still is there's actually two problems, right? The Meteor server itself on each EC2 instance still has slow data synchronization. So one of the things that's not commonly known is that if you have two Meteor servers connected that are running, sending data between each server actually takes 10 seconds. So a server only talks to another server every 10 seconds. So if I'm on one connection and another one's on another server, if we're updating data, we're not going to see each other's changes for another 10 seconds. So the solution to this is actually hidden inside the database. So MongoDB, if you're running a replica set, actually has this thing called an oplog, which essentially is it has a thing called oplog, which essentially fixes this issue. Because what it lets you do is each server can essentially connect to the MongoDB oplog, which basically, and the oplog is essentially a stream of new reads and of new writes that are happening inside the database. So instead of the servers actually connecting to one another and sending data back and forth every 10 seconds, they're essentially getting a real-time stream from the Mongo instance itself, getting data to each one of these servers, and each server is getting this data in real time as the Mongo server is processing it, so that the server itself can update the data update the data in real time instead of waiting 10 seconds and push that data to each of the clients. And I would definitely love to go more in depth on how exactly this works and why it's so good. But basically, it's essentially one of the solutions, one of two solutions that will solve the multiple server problem. And currently, you can use the Meteor oplog branch in the Meteor repo, or use a package called Meteor Smart Collections that will let you actually take advantage of this and actually take advantage of multiple servers and this real-time updating. And of course, you have some extras. I'll skip over these really quickly. You can use CloudFront for CDNing your data. Simple things, just regular deployment stuff. Nothing Meteor specific, really. So I know we're almost out of time, but this is kind of what the diagram looks like. You have your DNS, Route 53 on top. Yeah, you have SSL termination, you have a load balancer, you might have your CloudFront, your scaling set up with your web servers, and your Mongo database at the very bottom. And that's, that is the fat the fat layer essentially. The Mongo database is doing all the work, making sure the oplog is running, sending all the data, all the updates to each one of the servers, and making sure everything is in sync. So essentially, the bottleneck, if you have this entire Amazon setup, is the Mongo database, and you just have to keep that's basically how fast can you write into the Mongo database becomes the bottleneck and the question you have to ask. So I definitely jumped through this pretty quickly, and one thing that I wanted to that we want to start is essentially we'll publish this so hopefully other people can see it. And essentially start doing a couple of things to actually make this process on building production apps easier. So things like building an app scaffolding system, more guides and tutorials, and we'll share that URL once we get there. But that's pretty much the what I had to say. Had to jump through a couple things, and of course the shameless plug at the end. We are hiring at Stream. A couple details about us. We're one of the larger scale Meteor apps. We're YC backed and venture funded. So if you're looking for a job or interested in working on Meteor stuff on a day-to-day basis, please contact us. Or feel to contact me if it's any other, if you have any questions or anything. Happy to answer questions now as well. Yes, yeah.
I have a question about caching. So one of the things you mentioned is like the database is the bottleneck, right?
Yes.
If it's interactions between users and ferrying those changes out to everyone who's connected, it seems like rather than worrying about how fast you can actually write to Mongo, given like the optimistic model that seems on the client in Meteor, couldn't you do something similar where you just write to a cache and then forward the event on and then write to a database later?
So the question was, instead of doing this, instead of making the database the bottleneck, where you're, correct me if I'm wrong, essentially instead of waiting for the thing to write to the database and then distributing it out, have a cache layer in between where you just write to the cache first and then distribute to the clients, and then the database can update itself. So yes, you can do that. There's actually a package called Meteor Cluster, which does something like that essentially. It basically uses Redis for the cache layer. So every database query that's done, database write that's done, it sends it to the Redis layer, which then distributes to all the servers, and then the servers update the clients. The oplog just happens to be a faster way to do that for a variety of reasons, and it's actually not. It's not that. It's actually faster to do that because I think from what I understood, and there was actually a presentation about this. But the Mongo instance, the primary, will actually write to the oplog as soon as it gets the write, which will happen. It's about as fast as having a Redis layer, and there's no material difference between the two.
So you're finding that you're not bound by I/O to Mongo?
No, yeah, not yet. Yeah.
I'm interested in the client layer. You've had a lot of the grouping system that you have in place.
Yeah.
Where does partials come in that? Because it seems like those groups have to be predefined and are pretty static files in there. But if I want something to move around,
Yeah.
let's say I want to have like a movie list or whatever shown a certain way in one template and then another way in another template. Usually I will put it in a partial and just like call it back. Where do partials fall in this model?
So usually you want to put them in a folder called common, /view/common. So that's like, for example, if you have a layout, you want to put it there, footer, sidebar, maybe this, because it'd be appearing on multiple pages. Or you might want to think about, and again, this is on a design preference. If this is appearing in two different views, maybe both of those other views should be in the same group as well. Maybe it should be the movie group, and then you have this partial, and then you have the other two, views in that folder as well. Again, a design preference, but yeah. And sorry, for anyone on YouTube, the question was, what do you do with partials, and how do you structure them within this, app structure here?
Any other questions?
Yeah.
This might not be Meteor specific, but when you've got sticky sessions and you're talking about the CPU dropping below 30%,
Yeah.
do you have to hold on to it to
So that's a good point. The question was related to sticky sessions. If even one user is on, is on another server, and you're scaling down because the CPU usage is less than 30% based on the auto-scale permissions, what do you do with that? Do you keep the instance alive? Luckily, so I don't think this is the case yet with Meteor, but because we have the oplog solution or the data synchronized solution solved in some sense, eventually you should be able to you should be able to just make the user go to any server, right? Because if you think about it, every server should be okay with any user connecting to it at any point because it'll be up to date in the sense that it'll have all the up to date data, right? But that's not the case right now with Meteor. So yes, you're right. You do have to keep the server alive until that one last user leaves. Yes. Yeah.
In the case where you're switching a client from one server to another,
Yeah.
when there's a WebSocket there or some long hole that
Yeah.
has to be renegotiated,
Yes.
how will that handled?
So the question was, in the case that you switch a user from one server to another, you have to renegotiate the WebSocket or the polling of some sort. How well is that actually implemented? Again, it hasn't been implemented in Meteor. You're right, that is a problem. And there's specific session state you might have to pass back in a renegotiation. That again, I'm not exactly sure. Maybe you'd have to ask the Meteor guys. I don't even know if this is something they would want to do on the roadmap.
Any other questions?
Yeah.
How did the conversation go when selecting Meteor as your platform for this kind of YC-backed startup you're doing? What were the benefits and trade-offs and the kind of things you guys discussed from kind of basing it off of this?
So the question was, how did the conversation go when deciding to use Meteor.js over another platform that might have more traction of some sort, especially because we're a company that's running this in production, YC-backed, whatnot. So I guess what we decided was we wanted to build a single page app because that's the feedback we got. And looking at the single page app frameworks, there was Angular, you can use Backbone and build around it, Ember.js, a lot of these other solutions. But I think at the end of the day, it came down to we thought that we knew the Meteor guys, and they're really approachable and accessible. B, it was this is exactly what we would have eventually had to build towards, right? Even if you're using Angular or one of these other frameworks, you eventually have to build a lot of this glue to make it work like how Meteor works right now, right? Basically, we decided that those two reasons were good enough that Meteor is a contender. And C, I would say we chose Meteor based on just evaluating it on how well it would work in all these conditions, right? Can it scale? Does it work well in production? Is it secure, right? And this is all after Meteor had fixed all these issues that you might have seen previously. And yeah, so I guess it is a risk, right? Using something below version 1.0. But I would say the benefits are really nice because you get all the data synchronization, reactivity, and all these other things that you would have to build yourself if you want that in the app. So yeah, that's the answer to that.
All right, thank you. Thank
Cool,
you, Sid.
thanks.
All right, next up we have Chris. Let's set up. Riddick. Can you go to Alice? And David. David Greenspan. Can you go back there and see Alice? Thank you. All right. Make sure that's visible. Do you need Thunderbolt?
No, not Thunderbolt, but is that?
That's Thunderbolt.
Oh, is it?
Yeah.
Oh,
Here you go.
jeez. What do I
There you
know?
go.
Apparently I have Thunderbolt. I didn't know that.
There you go. And
All
there's
set.
the power source. Where's your power source thing? Oh, you're that.
I should be okay.
All right.
Yeah.
All right.
All right. There's somebody in the back. How small is that text? Is that pretty small, huh? Okay.
All right, folks. Next up, we have Chris Mather. Chris is the prolific author of the Evented Mind screencasts, which many of you are familiar with. He has spoken at numerous previous Devshops, contributed screencasts to the book Discover Meteor, and you'll probably understand and learn a new concept every time you watch one of his videos. So this is Chris.
Hello. I guess the one hiccup so far is I can't find my mouse, but that's okay. We can try to just use the keyboard. And let me blow this up a bit so that people can see it. Okay, so I'll just start talking here while I'm fiddling with this. So this is a bit of a risky talk, I think. Yesterday I was talking to one of the founders of Meteor, Matt, and he was talking to a group of us. And he said, you know, I think we ought to just start talking about some design decisions like fibers and how the event loop works. And no one will care, and it'll be really boring, but we should just do it. And I'm like, Matt, you know, that's my talk tomorrow. It's on that subject. Should I change it maybe? And he was like, oh, no, go do it. It'll be great. So yeah, so that's basically the talk. And it's really intended for developers and for people who have been using the framework for a while. But I think to kind of get us started, it's amazing how much progress you can make with a framework like Meteor without really needing or knowing how the runtime works. And I think that's a good thing. I think that's a good thing because you can get a lot done. And you can be sort of productive with getting your ideas translated into something quickly. But as you start to sort of build more complicated things, or you run into some debugging issues or things like that, it helps to have a better understanding of the underlying semantics, I think. And some of those concepts on the web are difficult to find. So if you've ever done a search for fibers, I did some research for this and tried to find something on like explaining the event loop and things like that. I had trouble. So I thought that's what we would talk about today. So to start us off with that, let's take a look. Okay. The light, maybe? Yeah, kill the light. I think is the thing to do. So I want you to sort of close your eyes while we're killing the light. And I want you to imagine, we're going to just create a mental model here. And if this is already old news to you, I apologize. Just bear with me for about 5 minutes, and then we'll get to fibers eventually. Let's create a mental model for how the event loop works and what it means to be asynchronous. So I want you to close your eyes, or at least imagine that you're at San Francisco airport. And you're going to the airport, and you're a little bit late. So you're running to the security line. And now you get to the security line. And there's a bunch of bags. You pick one of these conveyor belts to have the X-ray scan your bags, right? And it's got a line. And you put your bags up on there. And then you wait into the last possible second to take your shoes off. And the reason for that is because you want to minimize the amount of time that your feet are on the ground, because that reduces the chance of getting a horrible disease. So you learn that here, which is a bonus. So as things are moving through this conveyor belt, it's one conveyor belt. There's only one thing that goes through this X-ray machine at a time. And if that X-ray machine stops, like for some reason someone leaves a water bottle or something in there, the conveyor belt is blocked. And so that's really the same thing as an event loop. I find it sort of weird to call it a loop, because as a mental model, that doesn't really make sense to me. So it's really a queue. And you're thinking of things that are going in a linear way through this queue. And sometimes it stops. Now, when sometimes something's in the X-ray machine, the guy will pull it off and will inspect it, because you left your water bottle or something in there, right? And they'll take it off, and they'll do some work that doesn't block the machine. So now the conveyor belt just keeps going, right? And more bags go through it. And so that work that's being done might be called parallel work, like, for example, when you're doing I/O. So I/O might be considered, I/O is something like you're opening a file, or you're making a network request. And when you're done doing that work, you might take the bag and you might put it back onto the loop. You might put it back onto the conveyor belt. So it starts at the beginning of the line, and there's already stuff that's flowing through. So when it makes its way back to the front of the line, it'll go through the X-ray machine, and you'll continue. So I want to kind of, with that as our mental model for an event loop, go through and look at what does it mean to be asynchronous. And then we'll go and look at fibers. And if we have time, we'll look at bind environment, which is like the gold prize if you've been using Meteor for a while and you've gotten some errors that you don't know about with bind environment. So what we'll start off with is I've got a method here called X-ray machine, just to drive home the metaphor, although we'll try not to go too crazy with this. And I've just called this function 3 times, right? So with an index of 0, 1, and 2. And when that's done, I'm going to just print to the console that we're done with these 3 bags. We've processed the 3 bags, right? So if I go over and I run this, as you might expect, we see on the right there that we inspect bag 0, we inspect bag 1, and then we inspect bag 2. And then we print out that we're finished processing the 3 bags. OK, this will get a little more advanced pretty quickly here. So the next thing we want to do is just introduce the idea of what it means to be asynchronous, right? So I'm going to call this function called find. I've just called it find to make it somewhat similar to Mongo and the idea of something that makes a network call. But find is pretty silly. Find just takes a function like you might expect if you're using a node, just a regular node application. And the callback function, as a first parameter, takes an error, and as a second, a result. And what I'm going to do is just print out the result. So keeping in mind this conveyor belt idea, when we call find, the idea of asynchronous means that we're going to put something back on the conveyor belt at a later time. That's all that really means. So in this case, we're simulating that by using a set timeout call. So the set timeout call says that in about 2 seconds, I want you to take this function or this bag and put it at the beginning of the line. It may not execute right away. It'll execute when it makes its way to the X-ray. So this would be the same thing as if you made an I/O call, like you went to Node.js and you said, open this file. And Node will say, OK, I'm going to delegate that to the operating system. And when it's done, I'm going to take this function, put it at the beginning of the line, and when it gets to the X-ray, it'll execute. So that's what it means to be asynchronous. So using JavaScript is pretty cool because we can take these functions and we can pass them around, and we can call a function at a later time once we've done some work. So in this case, it's not parallel. We're just setting a timeout and saying do this at a later time. But the same kind of function works for I/O. OK, now what we're doing here is oftentimes we want to wait for the result. So I'm going to run this function. And as you would expect, one of the main highlights of this part of the presentation was this frightening result, but I forgot to mention it. So because it's Halloween, the result we're getting is frightening. I want you to really notice that. It took me a long time to think of that. So what this is going to do is it's going to process these 3 items first. So it's going to go inspecting bag 0, inspecting bag 1, inspecting bag 2. And then at a later time, at about 2 seconds later, we'll get these 3 results almost at the same time, because they go through very quickly, right? And so that's why we see that we're done processing the 3 bags, and then at a later time, we get this frightening, ghoulish result. Now, most of the time, we want to just wait for the result, because there's nothing else we can do until we have the result, like when we make a database call. So we use this callback mechanism to wait. But if I put something down here just to sort of drive home the point, as you know, this will execute right away, right? Because we're not waiting. So we inspect bag 0, and then we call after, and then inspect bag 1, and then after, inspect bag 2, after. And then about 2 seconds later, we get our result. So what we can do is, we'd like to really be able to write this in what's called a synchronous style. And so this is a design decision that Meteor made, which I believe is a good one, which allows us to write something in a synchronous style without actually blocking the entire event loop. And I'm going to show you what that means. So let's say instead of writing find with function error result, and we just want to wait on the result. And then I just want to print it. This code looks a little bit nicer. It's a little easier to read, right? So what I want to be able to do is to wait until I actually have a result, and then I'll print it out here. But the goal is to be able to do this without actually blocking the conveyor belt. So we can use something called fibers to do this. And I found fibers to be a little bit counterintuitive. So let's just go through the example. So I've included fibers up at the top by just requiring fibers. This is just a regular Node application, by the way, nothing Meteor specific here yet. And what I can do is create a new fiber by just calling fiber here. And the first thing you'll note is that a fiber basically just wraps a function. And then we can run this fiber. And the cool thing about fibers is that in the middle of their execution, we can pause them and just pause that one function and let other functions that are on the event loop continue to execute. And so to do that, let's go in and change this find method a little bit. We're still going to use setTimeout to simulate an asynchronous function, something that puts something back onto the event loop at a later time. But this time what we're going to do is we'll get a reference to the current fiber. And I'm going to create a variable called result and assign it equal to fiber.yield. And inside of the timeout, I think it's run. We'll see. Ghoulish result this time. OK. So what we're doing is we're getting a reference to the current fiber, if there is one, using this global fiber.current. And then we're yielding the fiber. It's kind of a strange term. What it means is just pause this current fiber. But what is that? It's just this function. It's not anything else outside of it. So we're not actually blocking anything. We're not blocking the event loop. So let's run this just to get a more intuitive sense of what's happening. I bet like 3 people have probably spotted errors already, but we'll run, and then we'll debug. Undefined. Oh, because we don't actually return the result. Right? OK. So what I expect to happen here is that the output is the same as what we had before. So using the callback style, right? So we expect back 0, 1, and 2. And then later, when we have a result, we print out that result. And this time, ghoulish instead of frightening. But we wrote this code in a synchronous style, which was just basically easier to read. So that's how basically fibers work, and one of the key benefits they give us. Another benefit is actually it gives us the ability to attach variables to it, because a fiber is actually an object, right, that we can run and resume and do things with. And so let me demonstrate that. So how much time do we have left? 8 minutes. Oh, man, I'm going like a bat out of hell. OK. How many people in the room, before I jump into this, it might be too esoteric, so let me just check. How many people have been using Meteor for more than 4 months? OK, and how many people have run into this, your code must be run inside of a fiber? Should I ask how many people know what it means? Or let's find out what it means, OK? OK, so that's a very confusing error. And I think like what we generally do to fix that is we put it inside of a fiber, and it goes away. And that is the right thing to do most of the time. But you might want to have a little bit more intuition as to what actually is happening. And so I'm going to give you that intuition now, hopefully. So we're creating this fiber to run our code in. And we know that now fibers can yield, which it basically means just pause this current function, but let other functions run. Just pause this one. Well, one thing we might want to do is we might want to create a global variable that's accessible to to functions that are running. We might just want to have like a global variable out here that says like index. And the reason for having that global variable is maybe I just don't want to pass it around, right? Like I might not want to take this index here and pass it to this print function. I want the print function just to be able to get access to that index variable somehow without it affecting my method signatures. But the problem is I can have lots of fibers, and they can be yielding all the time. And so I need a way to attach a global variable to the fiber and to keep that variable attached to the fiber so that if it gets resumed, I have access to the right value of that variable. So what I can do is create an environment variable, a Meteor environment variable. I'm going to go a little bit quicker than I did before here. I've actually pulled out the relevant Meteor code into its own file and eliminated the dependencies just so that we can look at specifically what this is doing. And that's what this require dynamics node is. So what I'm going to do is up here, I'm just going to create a variable that's global, and I'm going to call it, like, I don't know, current index. How about that? Instead of equal to just a new environment variable. And what I can do with that is I can say current index dot with value. And this is how I set the value of current index. And then as a second parameter, I'll pass a function. And we'll just paste in this stuff here. Now in my print function, I might change the signature a bit so that it doesn't have to take this index anymore. It'll just grab the index from the global, the global variable. Just bear with me for 1 second. OK, so I'm going to override the print function. And this time, instead of getting the index, which is just a helper, a number there for printing, as you can see over on the right, what I'm going to do is I'm going to grab that from this global variable store. And the way I'll do it is to say current index dot get. It'd be helpful if I assigned it to something. And then I'll just get rid of it as a parameter. OK, so now I haven't had to actually create a method signature now for the index. It's just part of sort of the global environment that's available. And I grab whatever the current value is, and I use that. So now what I can do is run the function and pray. See what happens. Great. So we still get the indexes printed. You can see the 0, 1, 2, right? Now what happens if I just sort of get rid of this fiber? Yeah, I think this is probably the right way to do it, right here. And now we get this error message. And the error message says that Meteor code always has to be run in a fiber. And the reason for that is because this global environment variable, the way that it's called Meteor Dynamics works, is it takes this and it attaches it to the fiber. And so when it goes to retrieve it, if there's no fiber, currently running fiber, it has nothing to retrieve it from. And so it detects this condition, and it says, if you're not currently in a fiber, there's no way for us to grab the global environment variables for that. So a little bit esoteric, but the reason that this is important is because that's where we put Meteor puts things like your method invocation that contains the current user, for example, or the write fence that's used to track how many writes have been committed. So what you can do if you want to learn more is you can go and go into the Meteor package, and it's in the Node.js or dynamics_Node.js file. And you can see it's not very complicated, but where that error comes from. So hopefully this gave you, one, a better idea of what it means to be asynchronous, especially if you were new to Node or to an evented system. And then we looked at what fibers are and how Meteor uses them, and then why you're getting the error that says that your code must be run inside of a fiber by using global environment variables. So a little bit down in the weeds, but hopefully it was a little bit enlightening. And that's all I've got. So if people have any questions, I'm happy to answer them. I apologize to the non-coders in the room. Sure.
You mentioned bind environment.
Oh, yeah. Yeah, so, right. So what does bind environment actually do? So bind environment, if you're familiar with a closure, where you say, I want to take like the current value of all those global variables and just save them. So when you call bind environment, it says, what are all the current values? The variables are dynamically scoped. We don't have time to talk about that, I guess. But what it means is they could change as you go up the call stack. So it saves them all. And then when in your callback function, if it's not already running in a fiber, it will create one and make sure that when it creates it, it copies over all those global variables to the new fiber. I think showing an example would probably be the best way to see it. If you don't call bind environment, let's put it this way. If you call set timeout, for example, and you don't need any of those global variables, like you're not making any Mongo calls or something, then it doesn't matter. You don't need it. But if you want to save away like the write fence or something like that, and you have a callback that runs later, you need to somehow copy over those global variables to the new fiber once it gets created. Does that make sense?
Once the fiber is done, do all those variables are they in their original versions? Is it basically like a copy, like a by value kind of thing?
Mm-hmm.
Got it.
Well, by yeah, it's yeah. All right, yeah.
So it seems like this Fiverr's method of writing node server-side code makes it a little easier to digest, and it's nicer syntactically. Are there any pitfalls of using this? Like, does it make testing harder, or does it make anything less pleasant?
So the question was, are there pitfalls to using fibers? And your example was in testing and other things. I mean, I think the biggest pitfall is that most of the node libraries are not written this way. And so it makes working with NPM packages a little bit tricky. But really, it's not too bad. There's a facility to wrap them. I think it's just not well documented yet. So I've done a few videos, for example, on Evented Mind, where you can go and see how to do it. It's 10 minutes. So, but that's the biggest pitfall. In terms of performance, the big misconception is that there's some kind of performance penalty. If there is, I don't know what it is, because it's just basically a syntactic change. So, any other questions? Yeah.
So you say you can have like lots of fibers?
Yeah.
So are there like multiple different, I guess, queues you can have at one time? How easy are those to manage?
So I'm glad for that sign. Otherwise, I definitely would not repeat the audience question. The question was, can you have multiple queues? And so you're talking about the airport conveyor belt where you put your shoes?
Right.
Is that yeah. So think of that as like one-to-one with a Meteor process and with one CPU. And so there's one set of instructions being executed. You have access to one CPU. It's one process. So if you want 2 lines, you need 2 processes. And so you would create 2 Meteor processes or 2 node processes, right? Does that answer the question?
Yeah.
Okay.
So are fibers in any way multi-threaded or scheming up these other processes?
No. Node.
Single-threaded the whole way through.
Oh, sorry, right. So the question is it single-threaded? And this was actually I don't know if it's a mistake, but I'm going to call it a mistake in the documentation where it says that each request is handled in its own thread. I think that it was a little ambiguous. So it's not a thread in the sense of the operating system thread. A node is single-threaded, right? So it's one process, one thread. But fibers sort of act similar to a thread in the fact that they can yield. But the operating system is not randomly going to swap them in and out and schedule them for you. The user decides when it's time to yield. So it's single thread, single process. Other questions? Thanks for your time. I hope it was helpful.
All right, everyone, we have a few minutes between this talk and the next one, so feel free to go to the bathroom. There's one behind that whiteboard in the lobby, and yeah, we will. All right, friends on YouTube, we will be back in a few minutes. Resuming talks in about 2 minutes, so please find your seat. Thank you.
Well, this definitely is not a problem.
It's not mine. Do you want water?
I'll take a water.
All right.
Thank you.
Remember to repeat audience questions.
All right.
72.1. All right, everyone, please be seated. All right, next up we have David Greenspan, who is going to tell you about Meteor's new rendering model. David wrote AppJet, one of the very first uses of JavaScript on server, and Etherpad, the real-time collaborative text editor. After Google acquired Etherpad and open sourced it, David went on to work on Wave and then App Engine. He's a DOM guru. He's kickstarted a working group that's standardizing and documenting a new Markdown spec, and now he leads the Meteor UI project. So today he's going to be telling about that. David.
Thank you. So I thought I'd take about 20 minutes away from coding to tell you where things are at, where we're going. If you've been following all of my talks and the discussion on the mailing list, then some of this stuff won't come as a big surprise, especially towards the beginning. But I'm really excited to talk about some of the architectural decisions we're making and some of the stuff under the hood that just is going to make this a really firm foundation for the best UI framework out there. The big picture. There we go. So the current batch of work we're doing is a new rendering model. It basically affects how templates get rendered and updated, all the patterns for that. And we're trying to keep it so the API changes are minimal, but this will affect how people write their apps and really make things a lot easier because often, especially with interactions with third-party libraries and jQuery and embedded widgets and stuff like that, you do run into rendering problems where maybe part of your DOM's being re-rendered more than you'd like. So this offers fine-grained DOM updates and better jQuery interop are kind of the big ticket items here. These other 3 points are stuff that's coming down the pipe. It's stuff we're thinking about. Components, where you can kind of marry a template to a controller, meaning you have some local reactive state, you have some logic that makes your template kind of modular. And making these configurable and overrideable, which is really, if you do some deep thinking about what it means to have a UI component, a lot of it is how do you make this reusable in different contexts. Right now, if you define a template, you can use it for multiple places in your app, but you can't really set configuration parameters. You can't override parts of it. You can't have state that's local to each instance of the template. Well, you can, but the patterns for it aren't very convenient. So that's kind of where we're looking to and what a lot of this stuff is based on. But because we're overhauling the rendering model as part of all this work, we want to kind of get that out first and kind of lock down some of that. Animation hooks, something we're thinking about. Probably not going to be in there for 1.0, but for a forward-looking framework like Meteor UI, it's very important that we can imagine what it should look like, where it's easy to specify animations, it's easy to fire them off programmatically, have them take effect declaratively, custom animations. Frameworks like Angular have animation systems, but they're not that great. I think we can do better. So we're keeping that in mind. And down the line, we are going to have some exciting enhancements to templating. We're thinking about having inline expressions, so you can kind of do if statements, do math inside a template. And pluggable syntax providers, so you'd have a Jade-like syntax, different syntaxes for your templates. So That gold box, the new rendering model, is what we're working on and releasing first, and that's mostly what I'm going to be talking about today. So just to go over the old rendering model, just very concisely. In the old rendering model, it was considered okay to over-render templates, essentially. I've got a template here that has a title. It's basically some reactively generated text. I've got a reactive attribute, foo, and then I've got this template main at the bottom that invokes the main pane template with the data argument of my info. And it used to be that, you know, title changes, that re-renders main pane. The foo changes, that re-renders main pane. If the data argument to the template changes, that also re-renders the template. And the reason that's okay, even though we have this input element in the middle that we probably don't want to, you know, mess with, we had the patching algorithm whose goal is to not ruin inputs, widgets, and embeds through these replacements. And it required these hints. So like element IDs and names are significant. You can write your own preserve directives, and you can use this constant region thing that a lot of people have to use. And that was impressive computer science, but we decided that's too complicated. So new rendering model starts with isolating everything. So helpers in attributes, helpers not in attributes are isolated. They're recalculated and then patched into the DOM right there when they change. A data argument like myInfo doesn't necessarily cause any DOM changes, so that doesn't necessarily cause any re-rendering. Basically, the dependencies are passed along to the parts of the template, and if those change, then the DOM is updated. There are, of course, cases where you have to replace a whole range of the DOM, and we want to do that sparingly because we're not having patching anymore. It's basically, if part of the DOM is replaced, it's because of an if or an each, it's because of a custom block helper, and kind of lumped into that is dynamically chosen templates, like you have a blog or you have a routing system where you want to calculate programmatically what template to display. If that changes, then of course the old template goes away and the new one comes in. But that's basically it. So it's a simpler model, has some major benefits. Reactive attributes are more interoperable. You have things like Bootstrap that want to change attributes on elements, set classes, stuff like that. Templates are never re-rendered from above, so you don't have this problem that's a big problem for modularity where you have to write your templates assuming they might be completely reconstructed based on dependencies higher up in the DOM. And templates don't care if you modify their DOM. This is basically the death of the constant region. If your template has a div, you can put stuff inside that div. It could be like a Google map. It could be a different template that you've dynamically inserted because of, you know, Iron Router's layout system, say. And the template doesn't care. The template, you know, assuming it doesn't have to re-render, it'll just leave that content alone. And the patching algorithm was one of the big reasons we couldn't do that before, because the patcher would come along and it really didn't know how to deal with stuff it wasn't expecting to see. And this model is easy to reason about. There may be some times where something's re-rendering, you don't want it to. That's certainly the case now with the old, you know, the currently released code. So basically the difference will be you can track down where that's happening and know what to do about it. There's also some major changes that will affect how templates are written. And this is really, I've spent a lot of time thinking about these deep questions. What is template.foo? What does hash foo mean? What does greater than foo mean? It may not be obvious why it's important to think about these things, but a lot of it's come out of thinking ahead to a world of components and how those will be defined. Components might have template parts that you might want to insert them in different ways. So template.foo, one of the big changes, it's no longer a function. It's not a function that returns HTML. It's some sort of object that knows how to create HTML. It knows how to create DOM. And we're kind of like not committing to too much about template.foo, except that it does continue to support all the APIs you use, template.foo.events, .helpers, .created, all that stuff. But under the hood, we're working towards a future where it's a component class and where that's what it really is. And I've got some code examples of things that you can't currently do in the release code. You can't set a helper called greeting, say template.main.greeting, and have that helper be another template. And the reason you can't do that is because when you go to insert a template, when you type greater than greeting, it doesn't search the helper namespace. But you currently can do that on the branch we're working on. Another thing is template.main2. Here what we're doing is we're extending an existing template and we're replacing part of it with a different template. And that's hugely useful. That's, you know, for example, we have a login buttons package right now. It's basically, it's one of our only UI widget packages. So you drop in login buttons in one line, and then from there you customize it with CSS. Well, you can't customize the templates. You can't take a package that uses some templates and override just some of those templates while using the other ones. So that's actually really powerful. And that code also works on the branch, but with the warning that this is an experimental API. Template.main.extend hasn't completely settled yet as an API. But what we're doing is we're experimenting under the hood with this question of components and inheritance, because we know that's where this is going. We know we're going to have inheritance between components and mixed in behaviors and stuff like that. Hash foo and greater than foo. You use hash foo right now for block helpers like if, else, with, and custom block helpers if you've experimented with defining those. Greater than foo you use to insert a template. So the changes there are that both of these are going to be searching the template namespace and the helper namespace. You can have helpers that are templates. You can have templates that act as block helpers. It may sound confusing, but basically it's going to give a lot of new flexibility for cases like forms. This is kind of the example of a type of syntax for forms that we've had sitting on the corner of our whiteboard for a long time of like, we want it to be this easy to make a form. You have a block helper that's like the boundary of your form. Maybe it sets events. Maybe it has the state of the form fields. If you want a text box, you insert it like it's a template, but actually it's a component. And we don't have all the details of this worked out, like what is address, what is street, how is the reactive state stored. But what we're enabling is these things to be components. And what if you want your own kind of text box? What if you want to use the behavior someone else has written in a text box, but you want to subclass it? Or maybe text box is actually supplied by my form. Maybe you can have a form block helper that defines some of its own local components and then exposes those. So there's all sorts of patterns we might want to have here. And what we don't want to do is have to add new syntax down the line or suddenly realize that we don't have a component syntax and we need components. So if you have custom block helpers, if you're curious about these changes and how they will affect you, you should definitely check out the mailing list. I'll have some pointers at the end of the talk, but there's a wiki page on the changes. If you're on either Meteor Talk or Meteor Core, you probably saw an email go by and there's a whole thread going with people trying out the code. Under the hood, I think under the hood is actually the more interesting part because, yeah, it affects the syntax in this way or that, but we've done a complete full stack overhaul as far as the UI stuff. We have a new template parser and compiler. The code name is Spacebars. I don't know, it's just the code name. We have a reactive rendering abstraction. This kind of replaces Spark. It's called render buffer. Live range is replaced by DOM range. And we have an experimental class system that implements the sort of inheritance I was talking about. And we're not talking too much about that because it still kind of hasn't settled. So here's a sort of schematic of the old pipeline for taking in a template. The part to the left of the blue line happens when your project is built. So your template is parsed by handlebars parser. Which spits out an AST, which is an abstract syntax tree. It's basically just a JSON data structure representing the parsed template. When the code actually goes to run on the client, the handlebars interpreter pulls up that data structure, it walks through it, it makes calls to Spark. Spark makes calls to live range, and that's kind of how everything happens. The new pipeline is significantly different because instead of a parser and this data structure that's sent down, in the build step, your templates are actually compiled and they're compiled to code that calls this render buffer API. So you have compiled JavaScript for all of your templates. You can view this in the source inspector in Chrome. At some point, we might even have source maps, so your handlebars template shows up in the source pane of your browser. We can do all that because it's compiled JavaScript. And then when the compiled JavaScript goes to run on the client, it's calling into this new API that's the render buffer, and the render buffer uses this new thing called DOM range. And so like, here's a cool thing we can do. DOM range can talk to jQuery, and it can support animation hooks. And these are kind of like bidirectional, multi-directional interoperation. So like, if you remove part of the DOM through jQuery, assuming you're using jQuery, if you remove part of the DOM through jQuery, Meteor can find out about that. It can hook into jQuery. In the other direction, if you have something like a jQuery UI widget you've embedded in your page, and it's listening for jQuery to tell it when some DOM has been removed, we will actually send the appropriate notifications to jQuery to make sure that that all happens correctly. Animation hooks means that if Meteor is doing some structural operation, like an if is changed and each needs to be updated, you'll be able to hook that, and you'll be able to use jQuery in those hooks, and all of that will just work. Also coming in the future is the prospect of other template languages, which compile JavaScript. Basically, we're creating the perfect target for other template engines. So if you want to have other syntaxes, if you want to have other template engines that also consume HTML, like EJS or something, that will all be possible. This API is also something you can write to by hand. It's going to be what's in your block helpers and custom components if you want to use it. What does that API look like? Well, I was working on cleaning it up this week, and I was hoping to have a really cool demo where I like open the inspector and like everything looks amazing. But what's coming is this syntax where you can declare your HTML in this nice kind of functional style. And this will be actually what your templates compile to. This will be what runs them under the hood. And you can also, write fragments of HTML in this form if you want. This also puts Meteor UI on a nice footing where it doesn't depend so heavily on space bars and the build process, because you could imagine using this API outside of Meteor in other contexts. And this is sort of a lot like what other frameworks are doing. Like Facebook's React framework essentially has a syntax like this. And then what they do is they have this syntactic sugar on top of this syntax that lets you write HTML tags in your JavaScript. That's not really our style to like parse HTML in your JavaScript code. We have .html files for that. And we also want to support different template languages. But the idea of having this intermediate representation that's kind of a target for HTML compilers, I think is sound. It's more HTML aware than Spark. Spark didn't really know about HTML attributes that much. It didn't really know when you were in a text area or a style tag. It kept us from making some of that stuff reactive. So yeah, there's a bunch of kind of reactivity features that this will let us do. And in the future, we can also be smarter about SVG, which we have sort of like partial support for right now. But with the popularity of things like D3 and Reactive, and the fact that we have a reactive system, you can imagine that SVG would be a very appealing thing to be able to just drop in. And an interesting thing about this example is that this function literal is essentially like a spark.isolate. So it's this little kind of domain-specific language where every time you have a function literal, it just becomes reactive. And I look forward in a future talk to talking more at like a lower level, because I think this is really kind of at the heart of the new Meteor UI. And there's a way, like when this API is ready, I think like a documentation of this API will just make it so Meteor UI is a very graspable thing. It's very like, okay, you've got all this template parsing stuff. We don't really know how that works, but it spits out this representation. And then this representation just makes your DOM reactive in particular places. And we don't know how that works either, but it's pretty clear like what's going on there in the end. Since I mentioned replacing DOM range with live range, I'm just going to replacing live range with DOM range. Just going to try to like show quickly pictorially what that difference looks like. So here we have a list. Inside that list, we have an each. Inside that each, we have an if that maybe sometimes spits out a list item, sometimes doesn't. And these white boxes represent the live ranges that you get in the DOM. You can't usually see these. They're kind of very tucked in. But if you've looked at Spark or watched some of Chris Mather's videos, you might have seen some of this. So live range has these strong bidirectional pointers. It kind of assumes the DOM is going to be pretty much how it left it. You can see that if you were to just come in with jQuery and really shake up this DOM, remove an LI that's on the end here, like move them around, it would just move these pointers around. That would be a disaster. So what DOM range is, it's a lot more like a kind of spider web that ties together these constructs between two levels of the DOM. So you've got the UL, you've got these LIs, and in between you've got this kind of bookkeeping that has to know that there's these eaches and ifs are there, so it can go in and toggle them if something becomes visible, if a new item gets added. But all the pointers pointing down the tree are weak pointers. So if you come in with jQuery, you remove an LI, you move these around, everything is still consistent. And we have even more ambitious plans for how this is going to work with jQuery and animation, where you can do even more than that. You can move these through Meteor and jQuery. You can have like jQuery removing something and Meteor trying to add something, and it'll all just work. Okay, so I'm running out of time. Status is being developed on the Shark branch. It already runs most of our example apps, which is a big milestone. There's a lot of discussion on the mailing list, and there's a wiki page about the user-facing changes. We're preparing release tags. So on the mailing list, this is something we like to do. We say, okay, now try your code with template engine preview 2. And if you pass this flag to Meteor, it'll run the app with a different release than the mainline release. And you can also use this with like Meteor deploy. You can deploy code on different releases, all without using Git. So in the interest of not over-promising, I'm just going to say coming this holiday season, I'm working around the clock on it, basically, and trying to see how soon I can land it on Devel so we can start hacking more on it, and then how soon I can get it released. So thank you. Are there any questions? Yeah.
What is strong and weak pointers?
Oh. A weak pointer, The question was, what are strong and weak pointers? JavaScript doesn't have weak pointers. I wish it did. I think it's going to get some form of weak pointer at some point. The idea is basically you're pointing at something, like you're pointing at an object, but you don't care if that object goes away. And in particular, in garbage collected languages like JavaScript and Java, it means you're not retaining that object. You're not keeping it in memory. So weak pointer to something is you can get to that object if it's still there. If the object happens to go away, then you try to follow it, and usually you can check. You can say, is this still there? What it means applied to this case is that basically a DOM range is prepared for the elements in it to go away, and if every time it goes to follow one of these pointers, it looks to see if the DOM element is still in the DOM. If it's not, it throws up its hands and says, oh, well, I guess that's gone. It tears down the pointer. And in some cases, it'll actually keep a placeholder because it might, if it needs to do some re-rendering, it wants to kind of get to some reasonable state. But yeah, that's basically the answer. Yeah?
So the compiled JavaScript that you showed, the format where you have like H1 and it takes a function and it returns a session variable, that stuff's all really useful for Meteor, right? And presumably that's what spacebars will compile to. To what extent would it be useful for someone to write a handlebars compiler and a JSON compiler
I don't quite understand.
So how hard would it be to write spacebars without any of the reactive stuff so that you can use it with Jade or use it with EJS or use it with Mustache or use it with
How would you use spacebars with Jade?
Well, so Spacebars is a handlebars compiler,
Essentially.
right?
It's a handlebars-like compiler.
Yeah. And then say you wanted to use Jade. How much work would I have to put in?
Oh, to make a Meteor package for it. Oh, so the question was, how much work would it be to create a Meteor package for something like Jade, given this API? Is that right?
No, how hard would it be to take a Jade template and compile it to the same format that Spacebars spits out?
Yeah. Yeah, I mean, the goal is to make that really easy, essentially. Yeah, so yeah, the question was, how much work would it be to write a Jade compiler that compiles to the same format as the Spacebars compiler? I think the answer is it should be really easy. Like the sacrifice we've made since Spark is we were originally trying to make it so we could reuse the same implementation. So if someone had a Jade library that had a full, maybe it had a parser, a compiler, an interpreter, or whatever, and it would build up strings and buffers, that we would somehow be able to be completely ignorant of those inner workings and still magically make it all reactive. And what we're doing now is saying, like, we do want visibility into the elements. We do need to know the structure of the HTML. But we think we can separate the syntax of what you type from all this hard reactive stuff and make the syntax part really easy. And in fact, it's a lot easier to write a Jade parser than a handlebars parser, because an HTML-aware handlebars parser has to parse HTML, whereas a Jade parser just has to look at indentation and tag names, and the syntax is much more straightforward. So I think that should be really easy. Yeah.
You've been following the work that Google's doing with Polymer and Mozilla's doing with Xtags to create web components. And
Yeah.
how might that work with Meteor UI?
The question was, have I been following the work from Google in the form of Polymer and from Mozilla about web components, and how does that fit into this? I'm kind of keeping an eye on that. I think to the extent that some of it's based in extending browsers, I think that really gives me pause, because we work really hard to support the features that are already in existing browsers, going back to Internet Explorer 8 even. So to say that maybe at some future time browsers will have custom elements that inside the browser are expanded to other elements, I think that would be interesting. It's an interesting implementation technology to use for something like Meteor. I don't know if it's the right way to express components, to express the things you can currently express with templates like handlebars templates. It certainly doesn't subscribe to the idea that you should have handlebars in Jade. The thinking is that you should have HTML, and essentially browsers should be able to look at curly braces, or should give you the machinery you need to implement templates that way. So I'm kind of keeping an eye on it. I haven't seen anything that makes me want to jump on those technologies and syntaxes. I think there's a lot of stuff wrapped up in there that would be really great to see in browsers, though. Like the ability to parse HTML in the browser, but not evaluate the things that usually get evaluated. Like part of the challenge for them is if you have like an image tag and you have some template in the source field, well, usually a browser will start fetching the image as soon as the image tag is created. So one of the proposed browser extensions is put the browser in a mode where you can construct tags and not have them immediately do whatever that tag would normally do. Another is a system that's kind of like live range, where you can track parts of the DOM, but the browser will do it for you. But they can't be empty, and there's certain restrictions there. I'd love to see that in browsers. So I'm just kind of see what happens with that. I think custom elements are one way to express components. Our syntax is one way, and there's plenty of time to for it all to come together somehow.
We're going to take one question from Twitter. Josh from Vancouver has a question. Session is a global var, and that would normally be an anti-pattern, but seems to be used a lot in Meteor. Other approaches, question mark?
Yeah, I don't have to repeat that question, right?
No.
Yeah, we want to have a reactive state that's not global, that's scoped to a template. And I think the only reason we don't have that yet is just it's a hard design problem about how does that get initialized, how do you use it from handlebars. So something we're thinking about, I think we probably would have, if you'd asked us, you know, some months back, we probably would have expected to have an answer to that by now. It turns out you can actually do a lot with session, especially if you like generate strings to use as session keys. It's kind of a pain. We're gonna have an answer for that basically as soon as we can get it out. Like as soon as we can figure out what our answer to that is.
Cool. Thank you, David.
Thank you.
All right. At this time, would all the lightning talk speakers come back here and find Alice? Friends on YouTube, we will be back after a couple minutes. That's Tim Heckel, Timur and Jamal, Ronaldo, Josh Owens, James Gill, and Adrian Lanning. Alice will be briefing you briefly.
I'm on for 6 minutes.
Yeah, kind of. Okay. We have more chairs back there. Yeah. Hello, everyone. We will be commencing lightning talks very shortly, so please have a seat. If you wanted to grab a beverage, I hope you've already gotten one. Yes, there's lots of. Yeah, we have more chairs back there.
Well, you're last. If you want, you can sort of hang out nearby, and then, yeah. Actually, do you think you could hang out like sort of on this path?
Yeah. Yeah, that's good. All right, please be seated. Lightning talks are starting. Tim Heckel is up first. Tim is the captain of our Minneapolis meetup, and today he's going to be telling you about on the merits of being wrong.
Yeah, I guess what I have found is that Meteor makes me fundamentally a very philosophical thinker. When I discovered Meteor, a lot of things shifted in my brain, and I have a demo that I wanted to get to, but I just felt like the precursor to that was to talk about the philosophical underpinnings of why I chose Meteor. And to me, the concept that came to mind was this idea of how good it is that I could be wrong, and the merits of that. I wrote an app called slatebox.com. This app I've been working on for a long time. And I have a Microsoft background, which might be apparent given the jarring Windows background that you might see here, because I know that that's kind of a rarity with all of the Macs everywhere. At any rate, I've spent a lot of time in the .NET world with an API and C# and all of those good things. And I spent a ton of time on Slatebox in that regard, and I'm proud of it. But then, over time, I ran up against Meteor, and I realized I can do so much so quickly. And one of the ways for me to kind of get through the investment that I had in my own abilities and all of this stuff that I had kind of spent my energy and time learning, and then I said, oh, maybe that's not as valuable as I thought it was. And that's a really hard thing for somebody to walk into and say, what I thought I understood is probably not as valuable as I'm holding on to it. And so the process for me to say, maybe I should rethink what I know, maybe I should reevaluate the things that I'm holding close to me, it was a cyclical effect on me where I kept thinking, well, I do know so much, and then I know so little. And Meteor itself was it was just a barrage of newness to me, right? And so I ended up deciding that I would rewrite the application. Like I said, I was very indignant when I first discovered Meteor, thinking, how dare you presume how to make a better app? Because I know things like inversion of control, and how dare you question some of these concepts that I've held dear, from a statically typed, a compiled language, and all of these things. And so it was just this very jarring experience for me. And philosophically, I was in tumult about that. So I had to recognize the value of my own inadequacy in the process, and I think that's a very interesting and an important skill for developers to understand. So, yes, I have these broad existential questions that don't need to be answered. There's no reason to answer. There's no reason to question. But I do, and at any rate, this is just part of the process. And to me, to be able to give a quick demo of the app that I did write, I can't do it without kind of giving you a bit of a foundation, behind why am I even doing what I'm doing. So that said, I will show you very briefly this application that I've written. Originally, so Slatebox itself is here. And this is an app I've got I've been writing it for a number of years, and there's about 14,000 users that use it. It is just something I'm doing on the side. I have a day job, and I'm fortunate enough to work full-time in Meteor during the day as well, writing a very large-scale production application. So this Meteor thing is happening for me during the day, and very occasionally when I have the time, I can work on Slatebox off hours. At any rate, this is the existing application over, like I said, many years and many iterations. And then just for today, I decided to spin up a new Slatebox version on Meteor. I've taken the core kernel of what Slatebox is, and you're probably like, what is Slatebox? It is a mind map and concept drawing application. It's going to be an MIT open source kernel that anybody could use, and I'm going to have a robust documentation site too. But I guess it's leveraging the real-time collaboration and the reactivity that Meteor has baked in. And if I go to the site as a new user, I don't have to register anymore. I took away the need to register. And then I can basically just build out this concept. You have the ability to search for images that you can embed in the node, like a puppy, which I adore. Then, and the cool thing about it is, of course, I can share that then with anybody without having to register, and all of a sudden I have this reactive template that any user, of course, then will have the ability to do this kind of thing and draw and build out additional templating. And my whole goal here was to make this really fast and really easy, really simple. And the sweet spot turns out to be sweet spot turns out to be middle school. A lot of middle school kids seem to like this, and I've been getting a lot of more projects on the site that kind of just say, oh, look, I can map, where the red fern grows and how the dog dies or something like that. And it's fun. I love to see kids do that. I love to do this kind of thing. But it all starts again with that churning, like, oh, was I wrong all these years? And I wasn't really wrong all these years. I just wasn't fully right. So, yes, thank you.
Questions? All right, thank you.
Great.
Oh.
You're not wrong in the same way that the people that invented the transistor are not wrong.
Thank you.
Everything has places.
Yeah, right. The context, the history, the context of that time and that space. Right, I like that.
Oh, question.
Yeah.
I have more of a comment than a question. I also think those things that you knew from developing in those other languages in this environment can be really useful.
Yeah.
Right? So you bring knowledge to the table that a lot of people that are developing for these platforms don't have.
Right.
So you have unique contributions to it.
Right. So the comment was that the things that I've learned are not necessarily lost because there's value baked into those languages, and that I can bring that into the Meteor experience. Yep. Thank you. Great.
All right, next up we have Timur Bajrov and Jamal Mustafa. They are physics PhD students at Berkeley. And today they're going to be showing you exabyte.io, which is a supercomputing app store.
Check, check. Hi, everybody. We're at exabyte.io. My name is Timur.
I'm Jamal, and we actually want to start off with a question. Has anyone out here used a supercomputer or run a code on a supercomputer?
Oh. Nobody? We do. We are two physics PhD students, as Jade said, and we use supercomputers every day for our research. And
can we?
I think I do already.
Where's your mouse?
It's up there.
So we're going to show an app that we've been developing as kind of part of our research almost to help us out. And we wanted to talk about why we chose Meteor, and the reason is because it's really easy to use. We came here actually for the hackathon a couple months ago. They were really helpful, and being two physics PhDs, web development definitely isn't in our toolbox. So having an all JavaScript kind of like one language to learn type web framework was really attractive to us. So.
And the reason we're building this is because supercomputing in general is very complicated, and the user interface is not something that people put attention to. They're trying to make it really fast, but it's really hard for people who don't have expertise to start using it. And there are also many people who would be using it, but because of this barrier, they can't. So let me walk you through this demo.
So as I mentioned, one of the things we like about Meteor is it's easy to use. And one of the features we really like is its reactivity. One thing we want to do is actually make something that's really like responsive to the user and not have to re-render all the time. And one thing we created was this app store where people can go and select different apps, and you can choose an app. And we've been trying to leverage some of the nice packages that are available on Atmosphere. And one of the things that we really like is there's a lot of packages that we can use to do most of the heavy lifting, like creating a form. I'll log in first. So we can select this app and then actually have a form that we can just create almost kind of like in the templating system, just generate the form dynamically. And
auto form package.
The auto form package, thank you. And we can create the input and actually generate like a text file and run the calculation. And
so what's happening over here is that there's the calculation output is being posted back from the supercomputer dynamically in real time. And we can also see the performance graphs. They measured CPU and memory. We can see the API response, which is the response of the server on the supercomputer. And we can, for people who really attach to the console, we have the console implemented as well. And when we proceed to the results, we can see the electronic band structure, something that me and Jamal, people who do physics, use every day, which is useful. So if you want to know how to hack a supercomputer, let us know. That's it.
Question. What do you use for your terminal?
For the terminal, we use JQ Console and hook it up to our API service. Yep.
So is it for scientists, for fellow PhD students who build their applications using supercomputers? Is it this app store for them?
So the question was, who is this for? And as of now, I can say that it's mainly for scientists, but we're trying to lower the barrier for entrance for anybody who wants to do simulations. For businesses who, not the large businesses like Shell, Chevron, but some smaller scale businesses who would otherwise be using it, but they can't because there's a big barrier to start doing it.
at the moment, a lot of the high-performance computing market is dominated by the government, and there's not really many commercial options. And so we're actually trying to be able to port this type of, app store to actually be able to use Amazon or Google or something like this, where it's more of like a commodity computing rather than, government-funded supercomputing centers. So.
So if I get access to your platform and then run my own application, will it be run on supercomputer in UC Berkeley or something?
As of now, no, but in the future, we hope so.
What's that?
The question was, if Slava is going to connect to our service, will his applications run on a supercomputer right now? The answer is no. In the future, we will implement this too. We hope that.
Can I mine Bitcoins on your guys' website?
We'll think about it. If you pay us back.
All right. Thank you.
All right, next up we have Ronaldo Barbachano. You've probably recognized him from previous lightning talks. Do you have your laptop up here?
Do you need a laptop?
Okay. Ronaldo has previously talked about his hackathon projects and various other things. Today he's going to be telling you about Trail, Move/Instagram API powered by Google Maps visualizations. Yes. There we go.
Let's use Safari, why not? So I'm just going to log in here for a second. So if any of you are familiar with Moves, it's currently this application for your phone for Android and iPhone, and they have open access or open API access, but right now it's only supported by iPhone. So I made this visualization here. Let me hide that. Yeah, sorry. I think I put your computer, okay, it's awake now. So as you can see here, we have some lines. These are some of my personal movements, I guess you would say. So it permits you to enter dates in, like time ranges. And then it allows you to plot days in the past. So like, maybe I want to catch 60 days in the past. So now I can select these dates and then begin plotting them. So what it's doing now is it's hitting up the Moves API and it's downloading everything. Sometimes it hits the API, sometimes it doesn't. It depends on how recent the day was or whether you clear your data. Oh, I can clear it out. So when you clear out your data, it'll automatically download 30 days. The button's supposed to work. This thing over here is Fitbit data that I just kind of threw in there. But also when you click on a marker, it'll pop this up too, which will kind of give you more of the Moves data, and also gives you a summary of what happened on that specific activity or segment inside of Moves. So you can also isolate lines by clicking on them, and it'll give you an idea of what you were doing that day. And then it has most of the kind of existing Gmaps functionality. We can overlay weather and transit and that kind of thing. And then maybe I'll connect to Instagram real quick if I have time. So it's giving my access token and my latest Instagram feed here. So this is basically the work that I showed last Devshop. Okay, questions?
Cool, thanks.
Thank you.
All right, next up we have Josh Owens. Josh is part of differential.io, and he is going to tell you about an introduction to accounts entry.
Hey guys, I'm Josh Owens. This is Rye Walker. We're partners at Differential. We're a venture shop in Cincinnati, Ohio. So we do we build Meteor apps for our clients, and I guess we do cash work for some of our clients. We do part equity, part cash work for other clients. And one of the things that we've done over the past couple months, we've built, I guess, 15 apps now in production, deployed them to Modulus. One of the things that our designer kind of kept bugging us for was a package that was easy to customize when you sign in. So you can see the normal sign in here. This is just Accounts UI that we've set up. It's got the Google sign in, and we'll just do a quick switch to accounts entry. The goal is, it uses Iron Router. It's probably equivalent in my mind to a Rails engine. It uses Iron Router. It uses Bootstrap 3 as far as the design goes. Just a lot of the standards we tend to adhere to. Was it not working? So we did this earlier just so it'd be kind of quick to paste in and out. That's all right. So this is still a work in progress for us. We don't have everything completely done. Like, if you need to configure an OAuth account or anything like that, you still need to do that in the console or in the database itself. But we do have a lot of options. We've got sign-up codes, so you can restrict who's signing up if you want, that kind of thing. And so now you see in the top right-hand corner, we've now got this sign-in and sign-up link. And now we've got actual, it routes to an actual route there and pulls everything up. And then the OAuth stuff up top is actually hooked up. So it detects which OAuth plugins you have installed, and it'll enumerate those out just like it does in the account UI. So. Yeah, I mentioned the sign-up code. So you can just set like a secret code if you want to hand out to people, and they have to have that. So I think that about covers it. Sure. Is it going to be a package on Atmosphere? It is now. We actually release quite often, so we're usually like the top package. What's the name of it? It's just accounts-entry. Okay. Yeah. Sure.
Do you plan or did you implement the version with the old router?
The version with the old what?
Old router.
The old router? So the question was, did we implement a version with the old router? No, we didn't. At the time we started building this, actually the project we ported out of was on the old router, but we upgraded to Iron Router, and all our projects are using Iron Router now. So.
The reason I'm asking is because I'm using your code, but adjusting it.
Oh, so he said he's using our code now, but it's adjusted for the old router. So yeah, I don't think that's anything we plan to do, because we use Iron Router for everything at this point.
Yeah, router's not too big, but we could probably do that.
Sure.
Did you find that transition hard between the Coleman's old router and the new Iron router?
Did we find the transition hard between the old router and the new Iron Router? I don't think we did. We didn't have any like huge projects at the time. We were still just getting going with some of the apps when Iron Router came out. I think we have one app that we kept building in our meetup that was, it's called Lister.io, and that's still on the old router. One more.
Is it possible to do it in JavaScript rather than could you do it in JavaScript rather than CoffeeScript?
Yeah, so the question is, could we do it in JavaScript instead of CoffeeScript? We had a branch for a while where we were just compiling the CoffeeScript into JavaScript, but we did away with it. We prefer CoffeeScript, so we find it easier to hack on. But we could. All right, thanks.
Thank you. Cool. Next up, we have James Gill. You probably know of him or are familiar with his work on Mati.io, in-browser IDE. Today, he is going to tell you about a new logger for Meteor.
Hi, well, I'm James, as she said, and Mati is a kind of complex multi-component app, and we've thought a lot about logging, and we've tried Winston and Log4Node.js or whatever, and pretty much didn't like any of them. So we built our own, and my hope is that it might be something that would be useful for you guys as well. So let me sort of talk about why we think it's cool. Am I on some?
Here. You can keep talking.
Oh, yeah. So one of the things we found very important, of course, is logging at different levels, like trace, debug, info, warn, error. But also something that we missed from our log4j days back in the Java land was that the loggers themselves might have some name or some identification, and we can actually like get a handle of them for that. So let's just take this thing for a spin, and I will show you, and hopefully it will hopefully it won't be too small. So we have something that's actually a little bit noisy here, right? And oh, there's a bunch of things. Maybe there's Ron, Hermione, and Harry talking. So let's just quiet this for a second. Okay, so now we're just going to see the important things like the errors and the warnings, and that's great. But one thing we've learned is that Hermione has a lot of really interesting things to say. And maybe we don't care about what Ron and Harry are saying right now, but we always care about what Hermione is saying. So let's just always see everything she says, and everything else is pretty quiet. Like, okay. Harry, Harry is, he's warning, so we got to listen to him sometimes, but we're not going to listen to everything he says. But, so this is all cool, but actually, there's something even cooler, which is that maybe there's other packages out there, and we maybe would listen to like a whole package or quite a whole package at the same time. So let's listen to the order of the Phoenix here. So now all of a sudden Sirius, you see Phoenix, Sirius, and in a second Phoenix, Remus is there. But kind of Sirius is a little whiny, so let's shut him up. Or at least just, let's see if I can spell his name right. I always spell it wrong. At least ignore some of his stuff. It's like, okay. So now what we have is for the most part, we only listen to warnings and errors. Hermione will listen to everything. For the Phoenix people, well, we listen to info and above. Or sorry, for Phoenix people, we listen to sort of everything, except for the Phoenix Sirius guy that we only listen to sort of his info and above. So that's all cool. But what's even cooler is that in Meteor, of course, everything should be written both for client and server. So in this case, we can do all the same thing on the server. And it's a little harder to do sort of dynamic level changing, but you can, if you find an error from something, you can up the error for that component for the next 90 seconds if you want. Or you can just change environment variables, restart your app, no code changes, you have different levels. But what's also even cooler, because we do stuff in Node and Meteor, is we want the same package and the same interface for both. So it works for Node as well. So my vision in 10 seconds is I'd actually love it if I'm fighting some sort of bug, and I think, okay, I don't want to care about my packages most of the time, but right now I think the bug's actually somehow influencing with like Iron Router. So I want to just pump up the logging levels for Iron Router and see everything, and maybe quiet some components and sort of listen to more on other components. And so if we all put this in our packages, we can actually have a very good debugging tool. Thank you, I'm done. Oh, it's not quite on Meteor yet, but it is, you can clone it and do it. And I'll put it up on Meteor as soon as a couple people use it and iron out the bugs.
Questions?
How do you make it persist?
How do I make it persist? How do I make the levels persist? Well, I mean, so right now, part of the early stages is that it appends everything to the console and not to files, so that it doesn't actually persist yet. But you can sort of put in different appenders. The API for that's not super clean, but I want to make it cleaner. You can put different appenders that can write to a database or Redis or a file or whatever, and do it selectively. It's also very cheap. If you're not listening to an event, like to a log message, then it's very cheap. It's an event that never gets listened to. It's a very cheap operation, so you can sort of do everything and listen to only the things you care about to files, say. Any more questions? Great.
All right, thanks. All right, next up we have Adrian Lanning. Some of you might have seen his longer tech talk a few dev shops ago. Today he is going to be telling you about load testing Meteor apps.
Hello, everyone. So as your apps grow, you probably want to test performance. And we had this problem with my startup, Share 911. So what we did is created a load testing tool that uses the Grinder, which is an open source load testing tool that Google has used. But the problem was that the grinder is well, most open source load testing tools, they do a really good job of testing stateless web apps. So Apache, Nginx, Tomcat, that kind of thing. So Meteor, of course, is stateful. So we need something a little bit more. So the grinder has plugins. You can plug in DDP stuff. I'm just going to kick this off. So right now we're kicking off a test. We have one process running, one agent running, one thread running, and it's just doing this test 1,000 times. So we can see this is that was the log file. So the tests are complete. We reached a peak test per second of 265, and now the app has finished getting the results of those from the Meteor server. So this is an example system under test that is up in the repo, and if you want to kind of follow along, this is the repository. So right now, let's go ahead and take a look at what was actually happening to execute this test. So at a high level, this is how Grindr is constructed. There's the management console, which can run on your laptop. Then there are agent processes, agents. And you can think of the agents as instances in a cloud. And on these instances, you have multiple processes and you have multiple threads per process. So the console will send to these agents the scripts that are required to for the grinder to do its job of managing this, but also your configuration for your specific application. And one of the neat things about this current system is that you don't need to modify your application to load test it. And so essentially it's your DDoSing your own system. So that's why we say at the very top of the repo here, please don't load test sites on meteor.com. Do it on your own servers. So what can you do with this? You can do Meteor calls, method calls with parameters, subscriptions with parameters. You can do user login. There's a couple ways to do user login. You can do it with resume tokens, and actually I just pushed a ability to do it with an actual email and password pair as well. You can put a ton of them in there and it will randomly select which ones to use for the tests. You can do interesting things like ramping up your number of processes and do some delays between your calls if you want to test that kind of thing. So that's all the time we have. Thank you very much.
Questions?
Yeah.
So what's the advantage of using that against Phantom kind of testing?
It's a good question. So the advantage against something like Phantom is that this is very efficient. So when you spin up your test machines, if you are using something like Phantom, then you are spending a lot of time on that test machine to basically recreate a browser environment. And you really don't need to do that. So what this does is it gives you the essential parts that will test the server without having to worry about the other parts. So there's configuration here. You can tell it to go ahead and download the initial payload. It'll go through that, parse out the scripts and the links, go and fetch those from the server, but it doesn't actually do anything with those. All it's doing is loading the server, so grabbing those initial ones. Then it goes in and performs the login, if you choose for it to do that, and then subscribes to whatever subscriptions you set up, and then we'll actually perform the methods calls however many times you tell it to do that. So an example of what that looks like in a file would be this. So you can actually set the number of processes that you want it to use, the number of threads per process, and the number of runs that it would do. So you can simulate a number of clients very effectively. And I'll just scroll up here. This is kind of how it looks like for the subscriptions. So This is just JSON, and you can model it out as you like, and then basically you just, if you're using Vim, which you should be, you should just Shift-J, and then it does that.
One more question.
Okay.
Did you remember this theme for Halloween?
No, it's actually just a accessibility thing for the Mac. So if you do a lot of coding at night, which I for some reason tend to do, then it's easier on your eyes.
It is not a special theme for Halloween.
Yes.
Cool, thank you.
Thanks.
All right. That says subscribe. To be on December 5th, featuring talks from Ronaldo Barberciano on Meteor-powered maps, Kirill Zubovsky on his Scoutsy internal app, and core dev David Glasser will be talking about the next steps in scaling Meteor. The signups are now open on Meetup, and I hope you can make it in real life or tune in. Lightning Talks signups are currently open, and they will remain open until 1 week before the Dev Shop. So thanks for tuning in, and see you next time.